Hi everyone. So in the previous video we talked about how to use a least squares regression to fit a line to a set of calibration data. And so in this video we're going to look at how we can march through that process and generate a curve of our own on some sample data. So here's my sample data. And this is plotting some known distance from our ultrasonic rangefinder to a object, and then I'm plotting the voltage that comes out of my instrument. And so I know that I want to use these formulas in order to get myself the coefficients of the line that I am going to use as a calibration fit. And so I'm going to be summing up xi times yi, and I'm going to be summing up the squares of my input xi values. And so in this row here, I'm going to calculate for each of the data above it x times y and x squared. So for instance here I'm going to have x squared, which is 1 squared, I'm going to get 1. And then x times y, I'm going to get 1.0 times 2.1, I'll get 2.1, and so on all the way through this row. And so then when I populate that, I get this row of data down here. And then in this column, I'm taking the sum of each of the rows to the left. So here I'm summing up all my x values, summing up all my y values, summing up all my xi times yi values, and summing up all of my xi squared values. And so this 801 and this 385 are going to be what go into this term here and this term here respectively. And I'm also going to need my average y value and my average x value so I can plug it in over here. And I should note that n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as we would expect since I calibrated at 1 through 10. So when I go through, I see that my 801 is indeed this term. My average y value is the sum of my y values divided by the number of data points, so 11.47. The sum of my average x value input is 5.5, and the sum of my squares of my x inputs is 385. So I can plug those into these two equations and calculate my A1 and my A0. And so here I take my 801, I subtract my 10 data points times my y bar, which is 11.47, times 5.5, which is my average x. Take the sum of my xi squared values, 385, and I subtract my n times x bar squared, so 10 times 5.5 squared. I get an A1 value, my slope value of 2.06. And then I take y bar minus my A1 value that I just calculated, multiplied by x bar, and I get 0.129 as my y-intercept. And so what this says to me is that when I'm not putting in any distance for my instrument, so when I put my instrument at 0 centimeters, my voltage will output as 0.13 volts. So even at 0 distance, I am getting some output from my sensor. And so then I could do a sanity check and plot this data by plotting this function up against all of my data points and get a look at how those compare. And I think, let me see, 4.3, 6.2, 8.5, yeah. So that would be this curve here in data set number 2. And so you can see my data points agree fairly well with my calibration points. And so in the next video, in part 3, we're going to take a look at if I have generated this, used least squares regression to generate this calibration function, how can I get an idea of how much confidence, or conversely how much uncertainty, I have in the accuracy of that calibration? So join me in the next video and we'll take a look.